Welcome back to Module 14.1. In this lecture video, I'm going to show you how to reduce our rational expression to the lowest term. So here, the fundamental principle of rational expression says if P over Q is a rational expression and P, Q, and K are polynomials where Q and K are not equal to 0, then my P over Q can actually come from P times K over Q times K. What that really means is saying if I have a common factor on the numerator and denominator, they can actually cancel each other out. Okay, so that's how I still end up with P over Q. A simpler way of saying it is when we're reducing fractions, such as, for example, 4 over 6, when we're reducing fraction, we can view 4 over 6 as 2 times 2 over 2 times 3. Okay, so since I noticed the same factor on the numerator and denominator, I can actually reduce them top and bottom first. Therefore, my final answer is whatever I have left with, which is 2/3. Okay, so this is really no different than regular reducing fractions. Okay, but one thing is a little bit tricky is when we normally reducing fraction and write them in factor form, the multiplication in the middle indicates the numerator and the denominator got to be one term over one term before you can cancel them out top and bottom. So for example, with this 4y plus 8 over 3y plus 6, you cannot simply say, oh, the a and 6 can be reduced by 2, the y and y will cancel out. Okay, you actually cannot do that because the 4y plus 8 on the numerator is actually 2 terms. The denominator also have 2 terms. So you got to make them into one term over one term before we can reduce them top and bottom. And that's where the factoring comes in. Because after we factor, every time after we completely finishing factoring, all the entire answer is actually one term because all the multiplication between them. So for this 4y plus 8 on the numerator, as you can recall, the greatest common factor between the two terms is 4. So if I factor out a 4, then what should be left with is y plus 2. So between the 4 and the parenthesis is actually a multiplication. So after I factor out the greatest common factor, my answer actually indicate one term over, all right, my denominator is 3y plus 6. If I factor out a 3, what's left is going to be y plus 2 again. All right, so 3 times parenthesis y plus 2 is also one term. So once you're one term over one term, then you can cancel out the similar factors. So right now I'm viewing entire y plus 2 as one term by putting them in the parenthesis. So y plus 2 over y plus 2 cancels out. So the only thing I got left with is 4 over 3. Okay, that's how we reducing our rational expressions. All right, for this one, let's see what can on the numerator is 2 terms, so let's factor. So basically the general steps is always factor, then reduce. That's generally how we actually do these problems. On the numerator, I believe I can factor out an x. Once I factor out x, what I should have in the parentheses is 4y plus x. All right, denominator. Let's see, between these two terms, I can factor out another x. So what I should have in the parentheses is 2x plus 3. All right, so everybody's now is one term over one term. So I see the x's are the same over another x, so those two can be cancelled out. All right, this factor 4y plus x is different than the factor of 2x plus 3. So my answer got to be whatever is left. which is 4y plus x over 2x plus 3. So Mr. Chen, why don't you put them in the parenthesis? Well, it actually makes no difference if I write them in the parenthesis versus not in this case, because I don't have any other factor in front of my parenthesis other than 1. So I don't really need to put them in the parenthesis. Just more typing into the homework if you put them in the parenthesis. So you can actually write them as 2 term over 2 terms since they cannot be reduced. Okay. Now, if I have another factor that is left in front of my parenthesis, then yeah, I will put my 2 term in the parenthesis. And you will see it. You will see it as we go along on some other example. All right, this one right here, the numerator, I think I can factor out a y. So what's left is y plus 4 over, my denominator is a trinomial. For y squared, I can use y and y. For 16, most of us use 4 and 4, which will work out perfectly because my outer is 4, my inner is 4, so that gives me 8 in the middle. So since the last sign is positive and I need a positive 8y in the middle, then my 2 signs got to be positive. All right, so I see y plus 4. I see the factor of y plus 4 on the top and the bottom, and one of them in the bottom can cancel each other out. So that's all I can cancel. This y plus 4 is viewed together as one term. So it's not, so I cannot take this y canceled out with this y down there. Because down here is one term, which is different than the single letter y up top. So my answer, y over y plus 4. And that's all I have to do. All right, this one look a little bit complicated. Let's see what I got here. Greatest common factor, I do have one, which is x. I can factor an x out. If I factor out an x, what's left is 3x squared minus 4xy minus 4y squared. All right, let's see if this can be factored. This is actually a trinomial, as you can recall. The variable x is 210 power. The variable y is 012 power. So this is a trinomial. Let's try to factor this, okay, real quick. You know what? Let's move this guys down here. If I cannot factor it, then we'll just leave it like that. All right, 3x squared minus 4xy minus 4y squared. Let's see, what should I get? For 3x squared, I can use a 3x and x. For 4y squared, let's see. 2 and 2 maybe. 2y and 2y. So now my outer is 6. My inner is 2. 6 and 2 combined will give me a 4 in the middle if I subtract. When the last sign is negative, the choice for the sign is 1 positive, 1 negative. Since I need a negative 4 in the middle, I will need a negative 6 and a positive 2 in the inner. So my outer needs to be a negative 6 by 3x times negative 2y. So the other one going to be positive. All right, so if you don't mind, I'm going to erase this part because I already factored it right here. I'm going to keep this part kind of clean. So once I factor out my x, then the trinomial that was in the parenthesis can be factored again into 3x plus 2y times x minus 2y over this denominator. I think I can just factor out an x, so that should give me x minus 2y. All right, so once everybody's one term on the top over one term in the bottom, I can start cancel out the common factors. So x and x on the outside can be canceled out. X minus 2y can be canceled out. So the only thing I got left with is simply a 3x plus 2y on the numerator. So that's my answer. All right. Ooh, I like this one. This denominator right away is a difference of squares. So that's y plus 5 times y minus 5. All right, let's see the numerator. Trinomial. For y squared, I'm going to use y and y. For 10, I'm going to use 2 and 5. So now my outer and inner combined can give me my 7y in the middle. So my sign needs to be both positive to end up with a positive 7y. All right, so let's see who can I reduce top and bottom. I think the plus 5 can be reduced. So the only thing left on top is y plus 2 over denominator y minus 5. All right. Now, one less bit right here. Opposite in rational expressions. Basically, what it's saying is for a polynomial p, if you ever see a negative p over positive p, they can actually be canceled out, okay, where the answer is going to be -1. In particular, if you see a minus x over x minus a, technically they are actually exactly the same factor, okay? They just differ by a negative sign, so they should be able to cancel each other out, okay? So factors that are opposite sign should always cancel out and make your answer a negative. All right, so let me explain this to you real quick, okay? I'm going to write this problem here on the side. So basically, 4 minus 4y over 4y minus 4. I'm going to try to make the top look just like the bottom. So the first thing I'm going to do is swap the order of these two terms. That means I should have negative 4y plus 4 over still 4y minus 4. All right, so to make the top exactly like the bottom, I can actually factor out a -1 on the numerator. If I factor a negative on the numerator, -1 going to -4y, positive 4y times. -1, with my cursor, -1 going to positive 4 is -4. All right. Now, my two term in the denominator, let's pretend I cannot factor anything out other than 1. So I'm going to put my two term in the parenthesis to indicate I already factor out a positive 1. All right, so now what you see is the numerator and denominator has the same exact factor, so they should cancel each other out. So that just leave you with a -1 for answer. Okay, so this is going to happen every time. So all we have to do is look at this problem and kind of recognize, well, this problem, I got 4y on the back side, but down here, 4y is in the front. The variable is in the front. The top variable is on the back. So something is up. So if you look closely, the numerator has a positive 4. Bottom has a -4. The top has a -4y. The bottom has a positive 4y. So their signs for the same exact term are totally opposite. So that means they can cancel each other out. That will just leave you with a negative for answer. Okay. For right now, we're just going to write -1 as the answer. All right. So that's called the factors that are opposite. Okay. You can spot it just by simply recognize the variables are actually one in the front, one on the back, and their signs are exactly opposite for both terms. So technically, they are exactly the same factor, just differ by -1. All right, so that will conclude this lecture video on how to reduce our rational expression. And this is going to be the same technique we are going to use multiplying rational expression as well. All right, that will conclude this lecture video. Thank you for watching.